Now that you know a little bit about Arduino hardware, let's talk about Arduino software. Once you've downloaded the Arduino software, you can open it up and you'll see a new sketch appear that looks something like this. Right? It has two functions in it, setup and loop. And a function is a way to modularize code in software. And in this case, setup will take some arguments, or a function will take some arguments in these parentheses. In this case, setup doesn't take any arguments, and it will return something. In this case, it doesn't return anything either. It returns void, which means nothing. All right, so these are pretty boring functions as far as functions go, but we have setup and loop, and these are a required part of every Arduino program, and we call Arduino program sketches. All right, but these actually do important things. So what setup is going to do, you're going to put all of your code that you need to run once in here. So this is often where you place functions that will set pin directions, set them as inputs or outputs. You also might put things that you're trying to initialize in here. So if you're trying to initialize your serial port and set that serial port, you put that in the setup function. The loop function is actually quite interesting. So what happens in the loop function is everything you have, all of the code you have in this loop function will continually repeat until you finally unplug your Arduino. So it'll just keep going and going and going through that code, keep looping around in that code. A couple other interesting things to note with this bare minimum code. Each of these functions has some curly brackets. And these are defining the scope of that function. Everything that goes in that function are going to be included in these curly braces. And you can see if I select one, it highlights the other, which makes them fairly easy to find. You'll also see these comments in here. So these two slashes indicate that everything after this is a comment and is not meant to be interpreted as actual code. So if I put a comment, I might put comments in my code to explain to myself later on or to others what I was trying to do in that particular code. So I can have these single line comments. I can also have multi-line comments. So instead of a // I'll have a /*, and I could write, for example, my name in here. And when I hit enter, it'll automatically close the comment as well, which is really handy, and that's a function of the IDE. And now I might say this is a 351 lecture example, just to name this so I have some idea of what it is if I come back to it in a year. Right, and finally, even with this really simple code that does absolutely nothing, I can compile this and upload it to my Arduino. So two important things you'll want to do once you first download your Arduino software is go to this Tools menu here and go to the board selection. And make sure the board selected here is the board that you actually have. So all of you are going to have the Arduino Uno, most likely. You also want to select the port as the USB port that your Arduino is plugged into. And this can be a little tricky. Sometimes you might have to try a couple different ports to get something to work, or even sometimes open and close the software. But it's very clearly here not my Bluetooth port. It's going to be this USB port right here. Right, once I have all of that set up, I can actually compile my code. And so to compile code, I'm going to click on this check mark right here, and it's called verify. And compiling is going to take this fairly abstract language, and it may not seem abstract to you, but it's abstract to the microcontroller. And it's going to compile it down to something that the microcontroller understands. First assembly, and then ultimately machine code, which is a bunch of ones and zeros. So I'm going to click on this. Right, and it turns yellow. It's compiling the sketch down here, and once it's done compiling, it's going to tell me how many bytes of actual program memory this takes on my Arduino. So I have something like 32 kilobytes at my disposal. My 450 bytes is getting nowhere close to that. I'm only taking 1% of the program storage space on the Arduino. Right, but this has just compiled the code. This has just told me that there are no compile errors. Now, compile errors are something that's a little strange in your code. So for example, you're not using the correct syntax. So maybe I'm missing one of these curly braces. It's going to tell me that I have something wrong here. So in this case, it tells me that I have this function definition before I had a curly brace token. So it indicates I'm missing a closed curly brace right here. Sometimes these compile time errors are more descriptive than others, but we'll see a couple more of these later on. But once I can compile this, I can actually upload it to my Arduino. And once again, this doesn't do anything, so it's not going to be that exciting. And once it's done compiling, it will actually upload, and it's done uploading. But I won't see my Arduino do anything in this case. All right, let's actually make the code do something though. One of the key pages that I want you to have heavily bookmarked and use all the time is the Arduino reference page. So the website address is up here, but if you go to Arduino and then reference, you'll find it pretty easily. So this is a language reference that's going to tell you all the different things that the Arduino can do, and also provide you some of the syntax and help in explaining what these functions actually do. So for example, I can see those setup and loop functions right here. So the setup function is called when the program or the sketch actually starts. I can use it to initialize variables, pin modes, all of those kind of things. I can also go and look at some interesting functions. So let's actually turn on an LED with the software instead of connecting it straight up to 5 volts. Right? And to do that, I'm going to want to look at digital input-output. I want to actually set an output pin from my Arduino to a high value to that 5 volts to turn on an LED. Right? And so I can click through these and see what these actually do. So pin mode is going to allow me to configure a specific pin as an input or an output. So it sounds pretty important to do. I want to set a pin up as an output to turn on an LED. So if I go to syntax, it'll tell me I need a pin, I need a mode. The pin is actually the number of the pin that I want to control with this. And the mode, I have the options of input, output, or input pull-up that you'll use later on in the lab. For right now, all I care about is output. So I can go back to my sketch, and in that setup function, I'm going to set my pin mode. So I'm going to write out pin mode. I'm going to pick pin 4 as an example, and I'm going to set that to an output. Right? But that alone isn't going to do anything interesting. I also need to set pin 4 high. So if I go back to my reference page, I can look at the next thing in this digital I/O subset of functions is digital write. Also sounds promising. So I can click on this, and what this says is it's going to write a high or a low to a digital pin on my Arduino. The syntax is given down here. So I have a pin number, once again, which I'll use pin 4 because that's the one that I set as an output, and I can set that pin to either high or low. And it also provides me some interesting sample code that might be useful as you're writing your own code. So if I go back to my sketch, I can write in, and I'm going to put this in the loop. I could put it in setup, it doesn't particularly matter in this case. But digital write, I'm going to use that same pin 4 and high. And so if I compile this, it should compile correctly. It uses more bytes than it did with just an empty sketch, which is not terribly surprising. Now I can see potentially all sorts of other compile time errors. So for example, I can be missing a semicolon. So a semicolon is something that tells the compiler that you're at the end of the line, at the end of a function here. So if I'm missing a semicolon and I try to compile, it will tell me that it expected a semicolon there before this red line. So I put the semicolon back. Some other things that I might do that would be incorrect. I could, instead of in all caps using high, I could just write high here, and what it will tell me is that high was not declared. It thinks high is a variable, and I haven't declared a variable called high. Right? So in this case, high, this all caps high, is a constant. And if I go back to that Arduino reference page and go up to the variables and constants, it tells me high and low are defined constants, input, output are defined constants, for example. So I can't use those, I shouldn't use those as variable names. Some other weird things you can do is if I have instead of pin 4, I had pin 110 here. Keep in mind that 0 has the slash through it. If I wrote a capital O instead, I might see a compile error that looks like this, where it's saying, what is this operator O? This is a particularly tricky one, so make sure all of your zeros have that slash in it. In this case, I'm going to change this back to pin 4 and compile that, and then I'm going to upload that. And now one of the really tricky things is that the compile time errors can be fairly easy to catch. Sometimes they're rather cryptic, but they can be fairly easy to catch. Runtime errors, or trying to figure out execution errors in my code and my hardware, can be a lot trickier. So in this case, I uploaded to this Arduino here, and what I can see is I've set up the Arduino such that I have a wire connecting my pin to a current limiting resistor. I have the other side of that current limiting resistor connected to the LED, and the other side of the LED connected back to ground, which is how I should have things set up, but my LED isn't on. So what's going on? So if I look at this a little bit more carefully, I realize I accidentally plugged this into pin 3 instead of pin 4. So if I move this to pin 4, the LED turns on. So that's an example of a runtime or execution error. And the tricky thing with mechatronic systems is that those can exist in software or hardware. And so it really helps to modularize your code and try out every little thing individually to make sure that all of those work before you start adding them together into a much more complex piece of software. All right, and finally I wanted to talk about functions, because those are one of the ways that you can do that, modularize your code and make it easier to test. So if I want to create my own function, I can do that as well. So for example, I might want to set up a function that just turns on that an LED. Right? So I can do this in a one-line command digital write, but this just kind of illustrates the point. So I'm going to create the function. It's not going to return anything, so I start with void. I'm going to call it something descriptive, turn on LED, and it's going to take a pin number as an input. I put that open curly brace. As soon as I hit enter, it adds the closed curly brace, which is really useful. Right? And all this is going to do is execute that digital write command. So I'm going to set pin 4 to high. And now in my loop code, instead of calling digital write, I'm going to call turn on LED, and I'm going to do that with pin 4. Sorry, in this case I don't want to specify pin 4, I want to use the variable pin that's in my argument. So I'm sending 4 as an argument to this function, so it's going to digital write to pin 4. So I can upload that. You can see LED is off. If I hit this reset button here, I can see it start again. I release that, and the LED turns on. So it did the same thing that we did before, but now I've created a little function to do that, and that can ultimately help simplify my code, make my code shorter. I don't have to repeat things. Functions are wonderful in general.